A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
Hey, Herman and Corin. So we've talked about this issue in kind of pockets of our conversations before, but this has been a long-standing challenge I found since fully embracing agentic AI for code generation. And I feel like I can't be the only one who's running into this problem. I know that in some different environments, if you're in a collaborative development environment with GitHub, you're going to have a very different way of defining your environments, and possibly a proper standalone secrets manager. But for the huge amount of people who are getting into development now, or that maybe weren't developing as prodigiously as they are, and as it's become so easy to with Claude and other agentic CLIs, this is becoming a problem. So a day doesn't go by in which I don't generate a new API key. That might be an exaggeration. 3 days never go by. I'm creating API keys for different services I'm trying out and want to integrate into platforms. I'm a big fan of 1Password, and it's an excellent tool. It has the OP command line interface. And this is something we've seen traditional password managers become much more terminal integrated to support secret management for development secrets. And the only issue is that this, of course, if we talk about the blast surface for security concerns in AI, if we directly expose a password manager or a secret vault and the AI agent has, unencrypted plain text access to it, then that is potentially a big problem. So 1Password have been very, very conservative in their rollout of tooling. So there isn't yet, to the best of my knowledge, anything like an official MCP, which would probably solve 90% of the problem. Let's say that I'm creating a project right now, and I want to create an APK, and I'm using Expo, which is a really, really great development cloud that I've just discovered for doing all that heavy lifting of building Android apps in the cloud. So you don't need to install Android Studio, create an Android emulator, all that stuff that it is slow and very data intensive. Brilliant service. So I'm going into a repository and I say, let us try building this as an APK using Expo. Now I need to update my environment variables with my token for Expo from 1Password. This process of recording new credentials, fishing them out of 1Password, manually adding them to your environment variables, is one that might seem like just a few steps until you start doing it 10 times a day. And it becomes quite annoying. I'm constantly searching for my Gemini API key, OpenAI, Anthropic, OpenWriter, you name it, all the time. And one potential direction for developers is to put these in your bash environment. So you would literally hard code these into your bash RC, and they're always there. Now, from a security standpoint, that's a really bad idea to put a bunch of API keys just sitting there in plain text on your computer. And for that reason, I haven't done that. But I'm looking, Herman and Corin, there must be a more elegant solution to this problem. Ideally, I would say, okay, Claude, let us create an Expo app with this. Claude says, okay, I'm going to need your Expo API key. And instead of me having to then search for it, it would say, this is the password manager. I'm going to make an MCP2 call. I'm going to search. I'm going to find, got it. I'm going to copy this into the user's environment. Done. No need for me to do this kind of monkey work. So Herman and Corin, curious to get your thoughts. I'd be very sorry to leave 1Password, but I'm not adverse to the idea of creating a separate secrets manager to keep my development secrets separate from my my user passwords. So I'm just interested to get your thoughts on what are some alternative workflows and processes that we're seeing already roll out with different development tools. Over to you two.
You know, it happened again this morning. I was trying to spin up a quick prototype for that new project we were talking about, and I spent more time hunting down API keys and wrestling with my environment variables than actually writing code. It is this constant friction that just kills the creative flow. It feels like for every step forward we take with AI speed, we take 2 steps back in administrative overhead.
Herman Poppleberry here, and I know exactly what you mean. It is the classic developer tax, but it has become so much more apparent now that we are using these high-speed agentic workflows. Our housemate Daniel actually sent us a prompt about this very thing. He is feeling that exact same pain, especially when he is working on Android apps with Expo. He is basically living in the future of code generation, but his security protocols are stuck in the mid-2000s.
Right. Daniel was saying that as he moves more toward letting AI agents like Claude handle the heavy lifting of code generation, the security side of things is starting to feel like a massive bottleneck. You've got these incredibly capable agents that can write whole modules in seconds, but then they are sitting there waiting for us to manually copy and paste a secret from one password into a terminal. It is a total mismatch of speeds. It is like having a Ferrari, but you have to stop every 50 feet to manually pump the fuel by hand.
That is a perfect analogy. Daniel mentioned that while he loves 1Password and its command line interface, he is hesitant to just open up his entire vault to an AI agent. And honestly, he should be. That is a massive security risk. We are at this weird crossroads where the developer experience is light years ahead of the security protocols for these agents. Today, we are going to dive deep into this security paradox. How do we bridge the gap between secure secret management and the ephemeral high-context needs of these AI coding agents?
And we are going to look at why the current solutions, like just hard-coding things into your bash profile or manually injecting environment variables, are not just tedious, they are actually dangerous in this new agentic world. So, let us frame this properly. What Daniel is calling the agentic secret gap is really about the friction between local tools and cloud-based reasoning. Herman, why is this copy-paste habit we have all developed such a ticking time bomb?
Well, think about what happens when you copy a secret. First, it is in your clipboard, which is often unencrypted and accessible by any number of background processes. Then, you paste it into a terminal. If you are not careful, that secret ends up in your shell history. But the real danger in 2026 is the context window. If you are using a tool like Claude or a specialized agentic command line interface, that secret might be captured in the tool's own logs, or, even worse, it might be sent back to the model provider as part of the conversation history.
That is the context leakage issue. If the agent sees the secret to use it, it might remember that secret or include it in a summary later.
Precisely. And in a world where we are increasingly using these agents to collaborate, you might accidentally share a prompt log that contains a live production key. Most people do not realize that once an agent has a secret in its context window, that secret is effectively part of the conversation. If that conversation is stored in a database or used for further training, you have got a permanent leak. We are talking about secrets being baked into the weights of future models if we are not careful.
And Daniel specifically mentioned the struggle with Expo and Android development. When you're doing mobile development, you are constantly juggling different keys for different environments, like development, staging, and production. You've got your Google Services JSON, your APK signing keys, your Expo access tokens. If you're doing that 10 times a day, the temptation to just throw them all into a global bash profile is huge.
Oh, it is the path of least resistance. But then you have essentially left the keys to the castle under the doormat. If any script you run, or any agent you authorize has access to your global environment, they have access to everything. We need a way to give these agents exactly what they need, for exactly as long as they need it, and nothing more. This is the principle of least privilege, but applied to a non-human entity that thinks 1,000,000 times faster than we do.
That brings us to the Model Context Protocol, or MCP. This is something we have touched on before, specifically back in episode 701 when we were talking about the dawn of true AI agents. Herman, you've been digging into the architecture of MCP lately. Is this the missing middleware that Daniel is looking for?
It is the most promising candidate we have. For those who need a refresher, the Model Context Protocol was introduced by Anthropic as a way to standardize how AI models interact with local data and tools. It uses a JSON-RPC-based transport layer to let models read files, search databases, and call tools. Instead of every developer writing a custom integration for every tool, you have this common language. But here is the catch: corn. As of right now, in March 2026, there is no native secret provider specification within MCP.
So we have the plumbing for the agent to talk to our files and our databases, but we do not have a secure way for it to ask for a password? That seems like a massive oversight.
It is a reflection of how fast this field is moving. The MCP spec focuses on resources and tools. A resource is like a file or a database record. A tool is a function the model can call, but a secret is a third thing. It is a sensitive piece of data that should be used by a tool but never seen by the model. Right now, if you want an agent to access 1Password, you have to write a custom MCP server that calls the 1Password command line interface. But if you do that naively, you're back to square one. If the MCP server just fetches the plain text secret and hands it to the model as a resource, the model now has the secret in its context window. The secret has leaked into the prompt.
This is where it gets technical. How do we give the agent the ability to use the secret without it actually seeing the secret? Is that even possible?
It is, but it requires a shift in how we think about injection. In a traditional workflow, we think of the secret as a piece of data. In a secure agentic workflow, we need to think of the secret as a capability. Instead of the agent saying, "Give me the API key for Gemini," the agent should say, "I need to run the specific build command that requires the Gemini key." Then, the MCP server should handle the injection locally, behind the scenes, so the model only ever sees the result of the command, not the key itself.
That makes so much sense. It is like a waiter in a restaurant. You do not give the waiter your credit card and tell him to go buy the ingredients. You give the order, and the back-end system handles the transaction. The waiter just brings you the food. But the problem is that many of our current developer tools are not built that way. They expect the secret to be sitting in an environment variable called something like expo_token. If the agent is the one running the command, it usually needs to set that variable itself. And to set it, it needs to know it.
We are fighting against 30 years of Unix philosophy where environment variables are the primary way to pass configuration. Daniel mentioned that he is using the 1Password command line interface, the OP tool. He said it supports service accounts now, which is a step in the right direction. Service accounts are huge because they allow for machine-to-machine communication without a human in the loop. You can create a service account that only has access to a specific vault, say a vault called Development Agents. Then, you give the agent a token for that service account. It is much safer than giving it your master password, obviously. But even then, you still have the problem of how that token is managed.
If the agent has the service account token, it can still fetch anything in that vault. If that agent gets compromised through a prompt injection attack, a malicious actor could tell the agent to list every secret it has access to and print them to the console. We have discussed red teaming user interfaces with agents in episode 835, and prompt injection is still the #1 vulnerability. If an agent is empowered to fetch secrets, it becomes a high-value target.
And that is a very real threat. This is why I think the current Wild West of local AI agents is so concerning. We are giving these tools immense power without the guardrails we would insist on for a junior developer or a third-party contractor. We are essentially giving a super intelligent intern the keys to the server room and hoping they do not get tricked by a phishing email.
It feels like we are trading security for velocity, and in the short term, velocity usually wins. But as these agents start handling more production-level tasks, the cost of a breach is going to skyrocket. Herman, you mentioned context leakage earlier. I want to go deeper on that. Even if we use a service account, is there a risk that the agent just logs the secret somewhere we are not looking?
Think about telemetry. Almost every modern AI tool sends telemetry back to the developers. If your agentic command line interface is logging the commands it runs to help the developers improve the tool, and that command includes an injected secret, that secret is now in their logs. Or think about the model itself. If you are using a hosted version of Claude or GPT, they might be logging the full context for debugging purposes. If your secret is in that context, it is in their database. This is why the idea of ephemeral injection is so important. We need to move away from persistent environment variables. In a traditional setup, you might have a .env file sitting in your project root. That file is a liability. It is one accidental git commit away from a disaster. In an agentic world, we should be using something more like what we see in high-security CI/CD pipelines, like GitHub Actions.
Oh, I like where you're going with this. Talk to me about the GitHub Actions model and how it compares to what Daniel is doing locally.
So, in GitHub Actions, you use something called OIDC, or OpenID Connect. When a job runs, it gets a short-lived identity-based token. It uses that token to prove to a secret provider, like Vault or 1Password, that it is exactly who it says it is. The secret is then injected directly into the memory of the running process. It never touches the disk, it is not in the environment for other processes to see, and it expires the moment the job is done. The key here is that the secret is never part of the code or the configuration. It is a dynamic, just-in-time handshake.
We do not have that for our local machines yet. When Daniel is running an Expo build, he is the one acting as the security gatekeeper, and he's getting tired of it. He is manually doing what OIDC does automatically. He goes to 1Password, gets the key, and puts it in the environment. What we need is a local agent identity. Imagine if every time you started an Agentic session, your machine generated a unique, short-lived identity for that specific agent. That identity would be authorized to access only the secrets needed for that specific task.
That is exactly it. We need a way to say, this specific instance of Claude running in this specific directory is allowed to access the Expo token for the next 30 minutes. That is the future of scoped agent identities. It moves us away from the idea that the agent is just an extension of the user. Right now, the agent runs with your permissions. If you can read a file, the agent can read it. If you can see a secret, the agent can see it. But the agent is not you. It is a tool you are directing.
That sounds like a lot of overhead for a developer who just wants to build an app. Is there a way to make that invisible? Because if it is not invisible, developers will just bypass it.
It could be integrated into the MCP server. If the 1Password MCP server was smart, it wouldn't just be a fetcher. It would be an orchestrator. It would see that the agent is trying to run an Expo build. It would verify that the agent is authorized for that project. It would fetch the secret, and then it would wrap the Expo command in a subshell with the secret injected. The agent would just say, run the build, and the MCP server would handle the secure injection and execution. The agent never even touches the secret. It just initiates the process that uses the secret.
That is the gold standard. It solves the context leakage problem, it solves the prompt injection problem, and it solves the tedious manual work problem. But we are not there yet. The tooling is still very fragmented. Herman, let's talk about the second-order effects of this. If we actually solve this and give agents secure, automated access to secrets, what does that do to the development cycle? We talked about the future of programming languages in episode 1033. Does this change how we even architect our applications?
I think it leads to much more granular, service-oriented architectures. Right now, we often hesitate to add a new service or a new API because the overhead of managing those keys is a pain. If an agent can spin up a new service, generate the keys, store them securely in 1Password, and then use them in another part of the app without us ever having to touch a copy-paste button, the speed of iteration becomes insane. We could see apps that are composed of hundreds of tiny, specialized services, each with its own unique, rotated keys.
But that also means we are going to have a lot more keys to manage. Automated secret rotation becomes a necessity, not a luxury. If an agent is creating keys, it should also be responsible for rotating them. But if the agent doesn't have a secure way to do that, we are just creating a larger attack surface. It is like that old saying, more money, more problems. In this case, more agents, more secrets.
That is the risk. We could end up with thousands of forgotten, long-lived keys scattered across various services because an agent created them and then we lost track of them. This is why I am a big believer in the idea of scoped agent identities. We should treat these agents as distinct entities with their own permissions rather than just extensions of our own user accounts. This is where the conservative worldview on security and personal responsibility really comes into play. We have to be the stewards of our own data and our own security posture. We cannot just rely on the model providers to keep us safe.
And from a pro-American perspective, maintaining the lead in AI development means we have to solve these security challenges first. If our developers are slowed down by clunky security, or worse, if our intellectual property is being leaked through insecure agentic workflows, we lose our edge. We need the most efficient, most secure development environment in the world. We need to be the ones setting the standards for MCP and agentic security.
I couldn't agree more. We are seeing a lot of competition from abroad, and they are not always as concerned with these security nuances. But in the long run, the most robust system wins. If we can build a zero-trust development environment where agents can move at the speed of thought without compromising security, that is a massive competitive advantage. It allows us to build faster and more securely than anyone else.
So let us look at some practical takeaways for Daniel and everyone else listening who is feeling this friction. If you're using Claude or an agentic command line interface today, what is the best move right now, before these standardized MCP secret providers are fully baked?
The first thing is what I call secret scoping. Never ever give an agent access to your primary vault in 1Password. Create a dedicated vault called something like Dev Agent Vault. Only put the specific keys in there that the agent actually needs for the project you are working on. Use the 1Password service accounts to give the agent access to only that specific vault. This limits the blast radius if the agent is compromised.
That is a great first step. It is basically sandboxing your secrets. What about the injection itself? How do we stop the copy-paste madness?
Avoid global environment variables. Instead of putting things in your bash profile, use a local wrapper. There are tools like drenvor, even just simple shell scripts that can load secrets into a specific directory's environment. Better yet, use the 1Password command line interface's run command. You can run a command like oprun followed by your build command, and it will inject the secrets from your vault directly into that process's environment without them ever being written to a file or stored in your history.
So instead of telling the agent to set an environment variable, you tell the agent to run the command using the oprun wrapper. That way, the agent is just triggering the secure process rather than handling the sensitive data itself.
You are essentially giving the agent a secure path to follow. You are saying, I will allow you to run this command, and I will make sure the secrets are there when you do, but I am not going to let you hold the secrets yourself. It is a subtle but powerful distinction. It keeps the secret out of the agent's context window and out of your terminal logs.
And what about the developers out there who are building these agentic tools? What should they be advocating for?
We need to push for standardization in the MCP community. We need a formal secret provider specification. This would allow 1Password, Bitwarden, and others to build official, secure MCP servers that follow a common security model. We need to move away from these ad hoc, homegrown scripts that most of us are using right now. We need a way for an agent to say, I need a secret for this tool, and for the MCP host to handle the retrieval and injection without the agent ever seeing the raw string.
It feels like we're in the early days of the internet, where everyone was just figuring out how to connect things, and security was an afterthought. But we know better now. We have the lessons of the last 30 years. We shouldn't have to repeat the same mistakes with AI. We have the technology to do this right from the start.
That is the hope. But the speed of AI is so much faster than the speed of previous technological shifts. The gap between a new capability and a new vulnerability is shrinking. That is why this discussion is so critical. We have to be proactive. We have to build the security into the architecture now, before these agents are managing our entire infrastructure.
I'm curious, Herman, do you think we will ever get to a point where the agent itself is smart enough to manage its own security? Like, it knows not to log a secret because it understands the implications? Or is that just wishful thinking?
Honestly, I wouldn't count on it. Even the smartest models can be tricked. Prompt injection is essentially a way to bypass the model's internal safeguards by confusing its layers of reasoning. Security has to be enforced at the architectural level, outside of the model's own logic. It has to be a hard constraint, not a suggestion. You don't ask the agent to be secure, you build an environment where it is impossible for it to be insecure.
That is a sobering thought. But it is also empowering. It means the solution is in our hands as developers and architects. We can build the containers that these agents live in. We are the ones who define the boundaries of their world.
It is about building a better cage, not just a smarter animal. We need to provide the agents with the tools they need to be productive, but we also need to provide the constraints that keep our data safe.
Let's talk about the Expo case specifically. Daniel mentioned that he is doing this multiple times a day. If he uses a service account and the OP run command, he still has to authorize that service account. Is there a way to make that persistent but still secure?
1Password service accounts use a token that you can store in your system's keychain. Once it is set up, the OP run command can use that token to authenticate without prompting you for a master password every time. It is a one-time setup that gives you that frictionless experience Daniel is looking for, while still keeping the secrets themselves inside the encrypted vault until the very millisecond they are needed. It is the closest we can get to that OIDC model on a local machine right now.
That sounds like exactly the workflow he needs. It removes the monkey work, as he called it, but keeps the security posture high. It allows him to stay in the flow of creation without having to worry about leaking his production keys.
It is a massive improvement over the copy-paste panic cycle. And as the MCP ecosystem matures, we will see even more elegant solutions that integrate this directly into the Agentic IDEs.
You know, this whole discussion reminds me of when we talked about securing AI model weights in episode 71. It is the same fundamental problem. How do you use a high-value asset without exposing it? Whether it is a billion-dollar model weight or a simple API key, the principles of zero trust and ephemeral access still apply. The more powerful the tool, the more careful you have to be with the keys.
It is the same philosophy across the board, and these agents are the most powerful tools we have ever built. They are force multipliers for our creativity, but they are also force multipliers for our mistakes. If we give them insecure access to our secrets, they can leak them at a scale and speed we can't even imagine.
So, to recap for everyone listening, if you are feeling the agentic secret gap, the move is to stop thinking of secrets as strings and start thinking of them as part of a secure execution pipeline. Use service accounts, use dedicated vaults, and use injection wrappers like the 1Password run command. Don't let your secrets sit in your context window.
And stay vocal. The more we talk about this, the more the tool developers will listen. We need those official MCP secret providers. We need this to be a first-class feature, not a hack. We need to demand better security from the tools we use every day.
This has been a fascinating dive, Herman. It is one of those things that seems small until you realize it is the foundation of everything we're trying to build with AI. If we don't get the security right, the whole agentic revolution is built on sand. Or worse, it is built on a pile of leaked credentials.
But I'm optimistic. We have the tools and the knowledge to do this right. We just have to be disciplined enough to implement them. We have to resist the urge to take the easy way out and instead build the secure foundations that will allow us to scale.
Well, I, for one, am going to go clean up my environment variables after this. I think I have a few too many secrets sitting in my bash history from last week. It is time to practice what we preach.
You and me both, Korn. You and me both. I'm going to go set up a dedicated vault for my coding agents right now.
Before we wrap up, I want to say a huge thank you to Daniel for sending this in. It is such a practical, real-world challenge that I know so many of our listeners are facing. If you have a topic you want us to dig into, please get in touch. We love these deep dives into the weird and wonderful corners of the AI world.
And if you are finding these discussions helpful, do us a huge favor and leave a review on your podcast app or on Spotify. It really helps the show reach new people and keeps the conversation going. We appreciate every single one of you.
Yeah, it genuinely makes a difference. You can find us at our website, myweirdprompts.com, where we have the full archive of over 1,000 episodes. We are also on Spotify and most other podcast platforms.
Thanks for joining us today on My Weird Prompts. It is always a pleasure to nerd out with you all. We hope you found this discussion on agentic security useful.
Until next time, stay curious, stay secure, and keep those agents on a short leash. Don't let them wander off with your API keys.
Hear, hear. We will see you in the next episode.
This has been My Weird Prompts. Thanks for listening.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow Keep